Okay, here we go. We're going to look at geosynchronous satellites for a second. And what I'd like to do first is just sort of show you the development of satellites over time. Back in 1960, they actually had the first geosynchronous satellite that they put up. And in fact, the first like satellite presentations that were given were for the 1964 Olympics using the first working geostatic or geosynchronous satellite. So what is a geosynchronous or geostatic satellite? And basically it's a satellite that enables you to put a satellite above the equator of the Earth such that it orbits the Earth in 24 hours. And by orbiting the Earth in 24 hours, while and going in an east direction, obviously, because the Earth is also spinning to the east, you'll end up being above the same point above the equator the entire time. And one thing that's interesting is it has to be above the equator. If you were above, say, New York, which would be really handy, you couldn't stay above New York because you wouldn't be orbiting the center of the Earth. Because if you're above New York, you're in the northern hemisphere. And if you're orbiting the center of the Earth, that means you'd have to be over the southern hemisphere at some point. And so you can't do that. So the geostationary satellites must be above the equator. And in fact, if you look at this, you can see over time, as we got to more recent times, we have this set of satellites where there's a high density of satellites at this given distance, at just the right distance. And you see the tilt is related to the fact that the Earth is tilted on its axis in the picture. So you can see here this density of low orbit satellites that are close to the surface of the Earth, but still above the atmosphere, right? That's all these white ones here. But then you have these that are much farther away that are actually orbiting once every 24 hours, so they stay above the exact place on the surface of the Earth, which is great. So when you set up your satellite dish, you can point it straight at one location in the sky, and it'll always be aimed at that same satellite, day and night, day after day. So a very powerful thing to have thought of. And we first put one up there in 1960, I believe. Okay, so let's look at the math that we have to do in order to calculate where this would have to be. And when we look at this, you notice that we're going to use that same equation that we looked at in problem 1, but this time we have the r is what's unknown. So the t is what's going to be known. We know that t has to be 24 hours because that's the time for one day, which is what we need the orbit to be. So we'll take that 24 hours times by 60 to get minutes and times by 60 again. So we get 86,400 seconds. And that's going to need to go into this equation here. And it'll get squared, right? Because that's t squared. G we saw last time is known to us. It's 6.67 times 10 to the negative 11th. Mass, we still have the mass of the Earth here, just like we did on the last problem. And divided by 4 pi squared. Be careful that when you're dividing by more than one thing in the denominator, that you put parentheses around everything in the denominator. Okay? So we can just plug and chug in this equation. Cubed root, you got to know how to do a cubed root. I use raised to the power of 1/3. You can see that here. But maybe you use the cubed root function, which a lot of calculators have. That's fine. Okay? And if we do that, we get this fairly large number here, right? We're looking at essentially 42 million meters. And if we remember, the radius of the Earth was in the order of 6 million meters. So much larger than the radius of the Earth. And this number, if you recall, is going to be from the center of the Earth to the center of the geosynchronous satellite. But what's usually asked is, well, how high is the satellite above the surface of the Earth? And this is from the center of the Earth. So to answer the question, how high above the surface of the Earth is that geosynchronous satellite, we have to subtract the radius of the Earth from this number. So we take the 42 million, we subtract the 6 million, and we see we get like 35 or 36 million. Okay? And so this is our final answer here. 35,800,000 meters above the surface of the Earth. And that's pretty far up there. And that enables it, right, to go fast, just the right speed in this orbit so that it takes 24 hours to get all the way around once, which is exactly as the planet spins once. And so it's exactly above the same place, right? And we never have to worry about these satellites running into each other and speeding up because they all are the same they're all the same distance away, so they're all moving at the same speed. They're all moving in the same orbit, okay? And this makes it look like there's a lot of them out there, but these pictures are not to scale. They put a little white dot for each satellite, but satellites are much smaller than what they're showing here in this scale picture, okay? And that's geostationary satellites or geosynchronous satellites. Hope to help a little bit. That's question number 2 as you prepare for your quiz, okay, next week. Good luck.